True,
temperature.
but that's not what Boyle
But
says.
that's not what it says. If you increase the pressure, you decrease volume. So V equals 1 over P.
Proportional to 1 over V. Yes.
Yes.
This is Boyle. And Boyle is buried at St. Patrick's Cathedral.
I think I remember that when we went down there to do
Oh, did you? Yes.
I think. And actually,
Oh, right.
the interesting thing about the whole thing was wandering around St. Patrick's.
Oh, so you were there for our culture night then?
Yeah, 2 years ago we went down. There was a choir thing on
Oh.
in you know, it's very
St. Patrick's.
St. Patrick's. So
Yeah.
it's around the same time as the one come in. Now
Yeah.
we did out at this time. I think it was just a little bit too, or something anyway messed up the plan.
Mm-hmm. Materials. Density is what we'll be doing today.
Ooh.
You remember that one?
I do. Density equals.
You know this one?
I do not know this one. It's okay, not over volume.
Mass divided by volume is correct.
God, that's a long time.
While ago.
I had to really scrape back the back of my brain there for that one. I had to access a dusty file sitting on a shelf back
Yes.
of a library.
Yeah. Do you have them on that? Maybe library, yes. Maybe library. Or maybe canteen?
No, not canteen.
No.
Because I was from the canteen.
Oh, you were just from the canteen.
They usually go to town again.
Yes, it's already 4:05.
Yeah.
What was your last class?
What? 3.
3-hour break. I wonder if this is a factor. Well, at last! Where's the rest? You didn't see them? Yeah.
It seems to be a popular theory.
Yeah. Yeah, and Faisal are where? You don't know? And the rest? They're in the library, you know. Okay. We'll have to start anyways, I guess. Did you want to...
I'll just hang on a couple of minutes. I'll let you crack ahead.
We'll start then, okay.
Yeah. I'll,
You can get some density stuff then. Yes.
Can I let us talk 25?
You need to do something?
The biology.
Oh yeah, you need that. Okay, that's fine. Yeah. Alright, so like I was saying, we'll start semester 2 today, and this section now is materials, which I said the last time is things like heat and temperature and all of that, remember? So we'll have a look at density, and we talked a little bit about density, I think in the first week actually of mechanics. Does anyone remember the formula for density? You do? You remember it? Yeah. Well, what's the formula for density?
Mass over volume.
Correct, mass over volume, yes. Density is mass per unit volume. And the units?
Kilogram per volume liter.
Not per litre, no, that's chemistry. Kilograms per...
dm.
Not dm, no.
cm.
Not really cm. The unit is kilograms per meter cubed. No, that's length. Kilograms per meter cubed. You remember this density formula? No. Lee? Yes.
I totally calculate in dm.
In chemistry, you use litres for volume. We don't in physics. We use meters cubed. Yes. So we're saying that it's mass per length cubed is for density. And the name of this Greek letter?
Huh?
The name of this Greek letter?
D?
Not D. You know this one?
I'm guessing it's
Go.
5?
Nope.
No.
5.
No.
You know this one? Close. Row. Row. Yes, so you were close. Okay. So what exactly does density tell us then? What do we know when we know the density? What is that telling us?
How much?
The area in
Yes, it's hard to explain. It's like how much is in a piece. Yeah. Okay, so we have some materials, of course, have a high density. Example being gold. Its density is 19,320 kilograms per meter cubed. So this means that per unit meter cubed of gold, we have about 19,000 kilograms. So it's a very dense material. And for something at the other end, what would be a low density? What's something that you know that would have a low density? Think air would have a low density. True. Yep. That would be one. Just as a little bit of a revision exercise with units, can you convert kilograms per meter cubed into centimeters per? Gram per centimeters cubed. You think you can do this one?
If I had it.
I don't really need a calculator for this one. Oh no, you went the wrong way. It gets smaller, not bigger.
you said
Here we are. Now, were you at the library by any chance?
Yes.
Oh yeah.
We went to A401.
Yeah, we went to A4.
What'd you do a silly thing like that for?
Because this morning we were in A401 with you and Max.
That makes a kind of sense.
Yeah, I think we maybe, put in some kind of critical thinking.
Where was the last place I saw Steve in person?
Yeah.
Yeah.
It is.
Did you get an answer here?
What you said.
I want it in grams per centimeter cubed. Yeah. Lee? Correct. 19 grams per centimeter cubed. Okay. And then just really quick, low density is something like helium. And helium has a density of 0.179 grams per meter cubed. So that is much less than gold. And you would know helium anyways from chemistry, right? Pretty small. Huh?
Yeah. It's smaller than air.
It's smaller than air. This is why it
Yeah.
rises, yes. Okay, so just before we continue there, you want to tell us something?
So we're missing Faisal,
Omar.
Yeah, and Omar. Is that right?
Yeah.
Yeah, okay.
Yeah, those three, yeah. Nat and Nadir, Faisal and Omar were missing.
Yes.
Okay.
I know Yahya, well, yes. Where, do you know where he is?
Good person.
Do you know where they are? No, okay, fine.
Anyway, that's no harm. I just wanted to quickly say to you.
Ah,
Hey.
no, hang on. What did I tell you this morning about being late?
Tomorrow.
You did tomorrow.
That's true,
Oh,
actually.
the loophole.
I told them this morning at 9 o'clock that if they're 15 minutes late, I'm not letting them in starting tomorrow, forgetting that I had this class later today. Yes?
Just for me, I was waiting to get to talk to Sylvia this morning.
Yeah, but if you're waiting to talk to Sylvia and it gets to 9 o'clock, well then you have to leave and then come back and talk to Sylvia later.
Yeah. It was 9:30 when he came by.
You can't ever use seeing Sylvia as an excuse. You have to
Yeah.
schedule. If you really want to see Sylvia before class, you go to half 8.
Yeah. Anyways, you are right. I did say tomorrow, but if you're this late tomorrow, I'm not letting you in the room, okay? So just sit down there. Did you see Faisal anywhere?
Yes, we were doing the coursework. And
Yeah. Sit down.
You connect. So class is
All right. Should I wait? Is he like right behind you?
Yeah, he went to the bathroom.
He'll be like a couple of minutes then. You can go ahead. So because it'll be 2 or 3 minutes.
Yeah, okay.
No, Faisal, why are you so late? Faisal.
And of course, of all the luck that I'm actually sitting here.
Yes, yes. Could you remember this morning you were late as well? Yeah. In future, if you're this late, it's starting to become a problem. I'm not going to let people in because it is starting to get annoying now that people are coming in at like 1/4 past the hour. Okay. So from tomorrow, do we have class at 9 tomorrow or?
We have a class tomorrow.
Or it's not 9. Okay. Anyway, it doesn't matter. If you're going to be this late, I'm just not letting you in. It's too disruptive now. Okay. So come on in. This is going to be everybody now then.
Bar or
Bar Omar, but he's not in today. Yeah, he's absent today, so he's not going to be in.
So I'll just take up 2 minutes.
Yep.
And then we'll get back into work. So basically, you may know that Connell isn't going to be around for the next 2 weeks. Okay. So I'm going to assume the course leader role 5 days away. Okay. So normally I don't encourage students to bother me unless there's something really, really serious happening. But in this case, I'll be dealing with more of the day-to-day stuff. Okay. So if you're going to be absent, you send me an email. Not Connell. Okay, send you an email and CC your teacher. If you need to send a medical certificate to document your illness, again, you can send it to me and I'll organise the attendance alterations. If you need to get an authorised absence to leave studying for some reason, again, come to me. If anyone ever needs to make an appointment, you just pop me an email. You all know my email address, tina@dublin.ie. So if you want to make an appointment, just pop me an email and I'll organise a meeting with you. Does anyone have any questions? Okay, great. Thanks. And if you wouldn't mind, I'm afraid that you're the class rep, so if you wouldn't mind passing that on to the students who are absent. Great, thanks Ellie. Thanks Stephen.
Okay, no problem. We'll continue then. We are starting materials, so we're doing density. Alright, so next slide then. So we have a high density is gold, low density is helium. So what is considered a medium density? What would you put something sort of in the middle? Water, yeah. We consider water as a medium level of density. And do you know the density of water? I need units.
1 kg per milliliter. Per liter.
We don't use liters in physics.
Centimeter cube. No, meter cube.
1 kg per meter cubed? That is incorrect. Picture a meter cubed. Picture a kilogram of water.
1 kilogram per
1
meter.
centimeter. 1 kg.
1 gram.
1 gram per meter cube.
1 gram. That is wrong. Come on, anyone know it?
1 kilogram per meter.
It is not 1 kilogram per meter cubed. That is too small.
1
centimeter cube.
And that is too big.
1 ton.
Per decimeter.
1,000 kilograms per meter cubed is water. Huh?
Is it 1 ton?
Yeah.
But he didn't finish it. He just said 1 ton and then stopped.
Yeah, 1 ton, like per.
Per what? That the per is important.
Is it not the same as 1? No, it's not.
You realise your question was going to be, is 1,000 kilograms per meter cubed not the same as 1 kilogram per meter cubed?
No.
Oh, I thought you were looking for the unit.
No, I didn't care about the unit.
Giving numbers.
I didn't.
You have 1,000 kilograms per meter cubed or 1 gram per centimeter cubed.
Yeah, that's the one.
That's the one you wanted. It's an important constant in science, the density of water. Because things that are less dense than water sink, and things that are float, and things that are more dense than water sink. So,
What things?
fall down in the water or go up in the water.
Like oil.
Like oil, yes, like oil.
What,
So,
what,
oil is less dense,
yeah,
so oil floats.
what thing?
Go down, like a rock.
But it's not.
Okay, a material, steel.
Let's see.
Um,
No, but you compare with water, it means liquid.
Oh, you mean
No.
give her a liquid example?
Yeah.
A liquid denser than water?
Oil.
No, oil is
Oil.
less dense. Custard.
Mercury.
Mercury, yeah.
Mercury, that's probably a better one than custard.
Yeah.
Mercury. You know mercury?
In the
Mine at the
thermometer.
moment.
It's not
Yeah, in the thermometer. Huh?
it's not
You know
Yes,
the
it is.
thermometer?
It's not a liquid.
Oh,
You know,
it's not,
in the chemistry lab experiments,
It
we
is
use
the only metal.
something
Is
to
it a
check
liquid?
the heat.
At room
That's the
temperature.
thermometer, yeah? There was something
All
red in it
melt
that
could
goes
be
up.
liquid at the right
That's
temperature.
mercury. It's a liquid metal.
What
It's
is
more
it?
dense than water.
Who?
It goes down.
No.
I answered it
That
like
is
I
so
don't know.
racist. So racist.
I was sleeping.
I apologize for Faisal's racism. You owe him one racist remark in return.
One word.
Make it a good one.
One word. Two.
Right, so density of gold is 19 times more dense than water. So this gives us our next idea, which is called relative density. It's the density compared to water. So for example, if the relative density is 2, we say it's twice as dense as water, meaning its density is what? 2,000 kilograms, yeah. So relative density, which is the letter S, is just defined as the density of the object compared to the density of water. And what would the unit be?
No unit.
Correct, it is dimensionless.
You read the email?
Yes, very profound.
Was an on spot? No, not on spot. In
Yeah.
the spot. Creation.
No, you're right, the first time on the spot.
On the spot, yeah, on
Yeah.
the spot creation.
You got this? No?
How can I write the density?
The symbol.
Yeah.
Oh.
It's like this.
Okay. P.
It's like a P.
Oh, this is you. The raw.
Density. But if you were on time for class, you would know this. Yes, we have this now? Okay. So one use for this is buoyancy, meaning the ability to float. If the S is less than 1, like wood, placed in water, it will float. If the S is greater than 1, like gold, and placed in water, obviously it will sink. So if S is equal to 1, you have something that is the same density as water.
And what would that
Yeah, it's kind of weird because it neither sinks nor floats. It can just it appears to move in a random direction through the water. So like, if you picture, you have water that's coloured, like red or whatever, and you put that into water, they obviously both have the same density. So if you imagine spilling red water into clear water, what will happen? Well, it'll just kind of mix around then, so just gets combined.
This only applies to solids or liquids as well? This S?
No, to solids, liquids and gas. Okay, continue? Yes, okay. Andrew, continue or
Yeah.
go on? Okay.
Question.
Yes.
Is the density affected by temperature?
Yes. It is, yes. Usually, but not always, usually as the temperature increases, the density decreases. There are some exceptions to this though. Right, so here's a table of some densities. Some I've already given you. So gold is 19,320 kilograms per meter cube with a relative density of 19.32. So we said gold is 19 times more dense than water. You'll need these values for some of the questions. So the first one is gold.
Do we need to memorize them?
What do you think?
No.
Correct.
No, of course not.
Continuing. So next we'll have a silver. Not, you might think it's kind of similar to gold, but it's, you know, nearly half the density of gold. It's only 10 times denser than water.
Does that mean it would sink slower than gold?
Yes, although still both would be quite fast.
Like they won't hit the floor at the same time.
That's not,
Well, the density will affect the buoyancy, which will affect the upward force, which will affect the total force, which will affect the total acceleration. You know?
F equals okay.
Thank you.
Oh.
Thank you, Mr. Newton. Right, next after silver is nickel. 8.9 times the density of water. Yes? After nickel, we have salt water. Interesting that salt water, you can see. The reason I put it in is because it's good to know if what's different between salt water and regular water. Salt water, one difference is it's a little denser than fresh water. Whereas fresh water, we said, is 1,000. Yeah. Very interesting. Next now is ice. Less than 1,000, 916, and that's why ice floats. Next is alcohol, 7, 8, 9, so even less dense than water, meaning alcohol would float. Yeah. Next is wood, which is not too different to alcohol, 700. Doesn't have the same effect on you, but it's about the same density, 700. And then finally is air. And compared to everything else, you can see how small air is. Air is about 1 kilogram per meter cubed. Oh yeah, you have to go to your interview, is it? Or test, or what?
No. For the dead people.
The what people?
Dead people.
Lithuania?
I know what that's the body in the city center.
Oh, they're doing an experiment on a dead body or something. They're gonna see
Cool.
some organs.
Cool. Take lots of pictures, please.
Don't think.
Don't
Humans,
they?
dead bodies?
Huh?
Humans?
Yeah.
Sounds like they're having some kind of live thing. Do you have the book for this?
Yeah. Let's
Tough break. Need the book for it. Is this with DIFC or by yourself?
Yeah, actually, I go with the biology class.
Well, well, well.
No, from here.
Wait, but you don't take biology.
She's in between.
She
Pharmacy.
gets to have all the fun she wants
Yes.
on both sides.
Can you take pictures? Let's see. Take lots of pictures for us, okay?
Okay.
Try not to vomit.
Yeah, don't get sick. Yeah.
She,
And the smell is not too bad, but it's pretty bad. Enjoy. Weird.
Give me some blood.
Yeah. Okay. Did you have this table? Yes. Okay. Next now. Let's have a look at some questions here. Do we need water for this one? We do. Fresh and salt water. Okay. So I'll let you try this one because it's actually not that difficult. The first thing is to convert litres into SI units. A litre, believe it or not, is not an SI unit. Okay? So what is the appropriate unit for volume? It's not litres, it's... No. Close. Meter cubed. Yeah. I mean, what unit do we use for volume? We use meter cubed. I know you could centimeters and decimeters and so on. So the first thing is I want you to change litres into meters cubed. That's the first thing to do. This is a question we actually did in mechanics, lesson 1.
1 liter, 2 meters cubed.
1 litre is 2 meters cubed.
2.
No.
1. Convert 1 liter, 2 meters cubed.
Yeah. Yes, correct. So convert.
Absorbing the information.
You have 1 litre absorbed, okay, and you want it into meters cubed.
Yeah, no, I'm thinking how many zeros, that's it.
Okay.
3.
No.
No. No zeros.
No.
No.
Between 1 liter is like this big. 1 liter cubed is
It's in the
like
power of
three.
minus 3.
Yeah.
One it is, one.
Cube. Okay.
Yep, 0.001 meters cubed is a litre because there are 1,000 litres in a meter cubed. So a litre is 1,000th of a meter cubed. As Lee said, 10 to the minus 3 meter cubed. Or 0.001 meter cubed. Can you write that down? You have that? Yep. Right, so part B, what is the mass of a litre of fresh water? And you can use the formula density is mass over volume. So what's mass equal to? Density by volume. Do you know the volume? You do now. Do you know the density? You do. Huh?
1.
Correct. 1 kilogram. C. What is the mass of a litre of salt water? Less than 1. 1.03, correct. If you mix these two together, what is the combined mass? The total mass, if you mix the two. That's right, it is as easy as you're thinking. 2.03 kg. What is the combined volume? 2 litres or, in meter cubed please? 0.002. Finally, what is the total density? That is 2.03 over 0.002. So can you calculate that please?
What did you say?
The total mass, which is 2.03, over the total volume, which is 0.002, which will be 1015?
Yeah, density.
Oh, sorry, density, yes, 1015, correct. 1,015 kilograms per meter cubed. Did you get that on the calculator? Yeah. That was an easy one. You could do it all in your head. It's just warm up. So I think, do I have a more difficult one now? Yes, I do. Well, no, this is a multiple choice. So I'll give you the situation and then I want to know if it's A, B or C. A student puts 10 grams of ice into some water. They close the bottle shut and there's no free space in the bottle. So the ice is inside the water, inside the bottle. There's no free space. Do you understand? No empty space. The bottle of water is left out and the ice in the bottle starts to melt. When it has fully melted, what happens to the bottle of water? So your choices are, the volume of the water has increased, so the bottle breaks. B, the volume of the water has remained unchanged, so nothing happens to the bottle. Or C, the volume of the water in the bottle decreased and there's a little space now at the surface.
Yeah.
So A, B or C, you're going with A?
No.
You're going with... Okay, you're thinking.
Oh.
You're going with B?
B.
B?
Volume.
B, yeah,
B.
volume,
B.
exactly. That's the whole point, it's
Yeah.
volume.
So you're saying B?
Yep.
And you're saying?
B.
And you're saying?
Because the ice, if it melts, it's not.
Doesn't mean it's not there anymore.
It's not
It's still there.
taking
Yeah.
extra space. It's just
Yeah.
taking the space of the ice, turning it to water.
Yeah.
The volume is
water
not
is
changed, but the
very
liquid
big.
is lower, but the volume
Yeah.
is still the same.
The thing, because it's the same volume.
It takes a larger.
Just the ice
It
becomes
takes a
smaller.
larger.
The answer is C.
What?
No.
When the ice melts, it goes from being a less dense material to a more dense material. The mass stays the same, so the volume decreases because you don't need as much space when it's now a more dense material. Yeah. Show them some love. That's it. Yeah. Don't listen to haters. Don't give in to peer pressure. So the answer is C. It contracts a little bit. Okay, very good. Right, now we're getting into a harder one. This one I will do, but I want to see if you can do it. Now, before you do it, I'll give you a hint. It's just, you need to think about it the same way we did this one, okay? We looked at the two liquids separately, and then we combined them. And the final density was the total mass over the total volume. When you combine masses, the total mass is just M1 plus M2. And when you combine volumes, it's V1 plus V2. Now there are some exceptions to that. So for example, in chemistry, can you give me an example of where you combine volumes? You have a V1, a V2, and when you combine them, the volume of the new combined liquid is, or gas, is not V1 plus V2.
When.
Because some escapes.
Yeah.
Now, just put everything in the container, no escaping or anything like that.
When it's changing state.
It could be change in state, correct, but something else, maybe.
The alcohol in the water.
I don't think so.
When the reaction is happening?
Yes, correct, when a reaction's happening. So, if you mix something like an acid and a base, maybe, what happens? Salt and water, a reaction takes place? Yeah.
Oxidation reaction.
Okay, so the volume will, what, change?
Yes, it changes.
The
It's
volume will decrease because
Yes.
salt is forming.
Yes.
Oh, I see. Salt is formed in the reaction and the volume then decreases. Is it? Okay, fair enough. So in physics we do not consider this. In physics when we mix things together in our problems, the total volume is just the original volumes added together. Same for mass.
Does it decrease or increase?
I don't know, this is a chemistry knowledge which I do
No,
not
but
have.
then when items like turn into solid, like when water turns into ice, the volume.
That's only water.
It's
Oh.
yeah, no, it is interesting and it is certainly worth talking about, generally speaking, if you were to graph for most materials, here temperature in Celsius, and here density in kilograms per meter cubed. So if you picture a piece of metal, we'll say, what happens when you heat metal?
Density increases.
No, just describe. Don't worry about having the right words. Just describe. It gets bigger. Yeah. Now density is mass over volume. So if the volume increases, what happens to the density? Decreases. So density decreases as you heat up the metal. So the graph should be going down, right? And water is nearly the same. For example, if you have water at 20 Celsius and you heat it to 30 Celsius, it will expand a little bit, and so its density decreases. So here is, let's say here is 10, and here is 20, so it'll decrease a little bit. But what's totally unusual with water, and it's only with water, and nothing else behaves like this, between 0 and 4 something weird happens. You would think the graph should continue going down, but at 0 to 4 it actually is increasing. I can't quite draw this in. So it's like it's decreasing, but then when it hits 0, it increases again, and then starts going back down when it gets to 4. So this is why ice is strange, because its density is supposed to be bigger, not smaller. Because what happens is ice to water, which is hotter? Water. So the density should be less here, and this one should be high, but it's actually the other way around. This is all unique to water.
But the volume is more
For ice.
for ice.
Yeah. Than for less for liquid water. This is unique to water. It's quite unusual. The reason why is not fully understood. So it's weird because if you picture a room, you know, hot gas rises. So if you have, I don't know, if you have some heat source here, it'll produce heat. So up at the top of the room, the air might be 20 Celsius, whereas down the bottom of the room, it will be 10 Celsius.
There's an experiment where
And yeah, you have the experiment where you can see the heat moving around the pipe. But between 0 and 4 degrees, water behaves opposite to this. If you had some water in a pond that was frozen, so on the top here is ice, this would be 0. And you think it should be colder down here because the heat rises, but it's actually warmer down here. And this is only for water between 0 and 4 Celsius. It has an opposite behavior. This is an important property for life because it means, for example, in situations where rivers and oceans have frozen, and this is at 0, the warm water actually sinks to the bottom. So the fish life can still survive at the bottom at a warmer 4 Celsius. Toasty 4 Celsius. So if you want to look this up more, you can. It's not really on the course, but it's just something very unusual and very interesting.
is when you freeze salt water.
Is it what?
Salt water.
Is it more dense than?
Good question. I don't know actually. My ice number I gave you is fresh water. I don't know what happens to salt water if its density is much different than frozen fresh
That
water.
wouldn't affect the earth because the water. I think it happens to salt water too. Like that. This happens to salt water.
Oh, it would still happen with salt water. It would still happen. I just don't know if the effect is greater or less.
And wouldn't salt water mixed with fresh water if they were put together?
Yes.
Like,
It becomes less salty and water.
Yeah, but usually it's a bad thing when salt water meets fresh water because it means you're losing a fresh water supply. Fresh water is more valuable than salt water. Salt water is not valuable. 2/3 of the earth is salt water. Only 5% of the earth is fresh water. So salt water's nobody cares about it. It's fresh water that you want to care about.
Boil it and make it fresh.
Yes, and this is what they do in Saudi Arabia. It's
Yeah.
called a
And
desalination plant. But you have to expend a lot of energy because boiling water takes a lot of energy. What?
And you can't drink tap water.
Where?
Yeah.
Got to know.
So then what's the point of it? Just to clean yourself?
Well, yes.
You can drink it, but like,
No one drinks it
no,
No one drinks it.
because they have,
because it's too hot.
yeah.
Oh yes, of course. Yes. It nicely warms up as it moves through the desert sand. This is
But water
Yeah.
is cheap anyway. Like
Yeah.
bottled water is really cheap. I think it's like 10 cents. No, 20 cents.
sure you can nearly take a shower in mineral water then.
No.
10 cents a litre.
No.
Quick
like,
shower.
For the
500.
small bottle.
Yeah, quick shower. Right, can you try this one now? It's like the salt and freshwater example. Okay, give this one a try. You definitely need your calculator. So you have a jeweler who mixes some silver with nickel. This is a real type of thing that they do. And quite common is they mix a lot of nickel with a little silver. So the jewellery item will look like silver, it'll be bright, it'll be shiny, it'll have the look of silver, but not the price of silver. Or the quality. Yeah. So, I want to know what is the density when you mix 10 grams of nickel with 1 gram of silver. Give it a try. My hint is to look at the first example you did with the fresh and salt.
No volumes.
Correct? Yeah, but you also have densities because I gave you the densities of nickel and
Oh.
silver.
True.
But it's not pure silver.
Huh?
It's not pure silver.
He's giving you the quantity.
Ah, japers.
The pure nickel.
I'll be back in 1 moment. Continue, please. Hello? Ah, yeah.
Okay.
Okay, guys, I'll just run, dudes, I'll just run through it on the board. We'll do it together, okay? So I didn't realise the time because I was looking at this clock thinking, I only saw the hand at 7 thinking, oh, still got 15 minutes, and only when I saw my phone I realised it's 3 minutes. So I'll just do this one now, okay? The density of the mixture is equal to the mass of the mixture over the volume of the mixture. Well, the good news is we know the mass of the mixture. What's the mass? 11 grams. Bad news, do we know the volume of the mixture? No. But the volume of the mixture is the volume of the silver plus the volume of the nickel. Do we have those? No. But if I look at this formula, what does volume equal? Volume equals mass over density. So this is 0.011, mass of silver over density of silver, plus mass of nickel over density of nickel.
Yeah.
Do we know the mass of the silver? Yes, we do.
10.
Do we know the density of silver?
Yeah.
Yeah, what is it?
10,500.
Great. Do we know the mass of the nickel? It's 10, isn't it, grams? And do we know the density of nickel? What is the density of nickel?
8900.
8900. So the number we get should be somewhere in between the two densities. If you hit that in, let's see what we get. What is it, Lee?
Yeah.
Kilograms per meter cubed. Is it more or less dense than nickel?
It's less than.
More
Than nickel.
More than nickel and less than silver. This should always happen when you mix two materials. The final density should be bigger than the small one, but smaller than the big one. It should be in between. If it's bigger than the bigger density, then you've done something really wrong, because you've mixed two materials together and have made something more dense than what you ever had at the beginning.
What's wrong with that?
It doesn't really happen in life. Yeah, unless when you mix it together you go, come on, like this. Then the density increases. Okay, you got this? Yeah. Alright, so your homework here, what have we got here? 5 questions.
Did we discuss today about homeworks?
Yes, for maths.
We also, like when I came in the class, they were like, apparently, like it wasn't in the last name, but then one was like, you said more.
Yeah, yeah.
Okay, more.
Good.